Welcome to Bite-Sized Data Science. Over the last two videos, we talked about text representation and document classification. There is still more to talk about when it comes to text processing. We saw that we want to have all the words in the same case to avoid duplication. We can do more. Instead of simply talking about it in a theoretical manner, I'll use a notebook to show how these different approaches work. I am using a notebook in the IBM Watson Studio environment. Take a look at the description below the video for a URL to create a free account on that platform. The description also includes URLs for the notebook I am using here. In this notebook, I'm using a natural language toolkit called NLTK. The first thing I want to cover is the concept of stemming. In an informal manner, you can define it as a way to reduce a word to its root form. Often, stemmers work on removing suffixes from words. NLTK come with multiple stemmers for multiple languages. In English, there are several choices. Let's look at a few examples. The first example uses the Porter stemmer. As we can see, the word gaming, game, gamed, and games were reduced to game. It even handled the initial uppercase of gaming. Let's look at some possibilities and compare the different stemmers available. We are comparing the Porter to the Lancaster and the Snowball stemmers. As we can see, they all have relative success with the different forms of game. They don't work for the different forms of the verb to be. It does not do so good on irregular form of plural, such as men, wolves, and abachi. Similarly, it can't handle irregular comparatives and superlatives. Finally, we see that surprise and surprisingly are handled pretty well. How can we do better? This brings us to lemmization. But before we can talk about this, we have to first talk about something called part of speech. There are 8 parts of speech in the English language: noun, pronoun, verb, adjectives, adverb, preposition, conjunction, and interjection. The part of speech indicates how a word functions in meaning as well as grammatically within a sentence. We see here on the screen a list of potential part of speech. It is more than the 8 mentioned above, but you'll notice that most of them are refinements on the 8 part of speech. If we extract the part of speech tags from the list of words we used before, we see that is, are, was, and were are classified properly as verbs. Still, we see some errors, such as wolves seen as a verb in the third person and abachi as an adverb. If we put these words in a sentence, like the one here, we can see that the NLTK part of speech tagger figures out that wolves and abachi are nouns. Now that we know about parts of speech, we can look at lemmization as another way to extract the root of words. We saw that stemming was a somewhat simple process of removing the end of words to get to the root of a word. Lemmization uses vocabulary, grammar, and morphological analysis to get to that root word. To do the job right, lemmization takes advantage of part of speech to figure out how to process a specific word. Let's look at our original list of words and pass it through the lemmize method. Note that the method also takes a part of speech argument. Since we're using a list of words, the part of speech is not completely accurate as we've seen before. We see several good conversions from game, the verb to be, and even better to good. If we apply it to a sentence, we see that with the proper part of speech classification, we get wolf and abacus. Both stemming and lemmization can be used to reduce duplication of words in documents. For stemming, the snowball stemmer would be a good choice. Note that it is a follow-up to the Porter stemmer. Still, there are results that are less than perfect. The lemmizer is an improvement over stemming in many aspects, but also can generate unexpected results. Since NLTK is an open source software, you could correct errors when you find them. So both stemming and lemmizing are good tools in text analytics. Keep them in mind the next time you need to process text. See you next time on Bite-Sized Data Science, and don't forget to subscribe.